Hey guys, I'm outside one of the few biofuel research centers in the world. Here, scientists are on a mission to find a fuel to help green up our planet. Let's head inside and see how they plan to do it. It's high-tech science that could change the future of fuel. This is JBEI, otherwise known as the Joint Bioenergy Institute. It's a place working to unlock some of nature's secrets, to create plant-based biofuels to replace fossil fuels.
Researchers here at JBEI are really looking at trying to create gasoline and diesel using fermentation that could be a direct drop-in replacement for gasoline and diesel that you use today, and also the aviation fuel that we use to fly around it.
Blake Simmons is a top chemical engineer working to develop this next generation of biofuels. Liquid fuels derived from solar energy stored in plant biomass.
Biomass is defined as anything that's photosynthetic, that utilizes sunlight and CO2 to grow, and basically produces polysaccharides into the plant cell wall. And so when you're talking biomass, it can be trees, it can be grasses, it can be mold, it can be moss. It can actually be a variety of different formats.
They're experimenting with inedible plants, grasses, and even trees. Sugar polymers inside their cell walls store the sun's energy. But unlike starches like corn used for ethanol, these sugars can be hard to get. This is the first step of the process, so what's happening in here?
So this lab is really working on the feedstocks, which is the origin of all biofuels. What they're trying to do is understand what are inside the plants that make them harder to process, and then come up with engineering methods to break them down easier and produce sugar very effectively. What they're doing is growing plants. We have a variety in here, as you can see, that we're growing. It's under very carefully controlled environmental conditions, so we can, really try and understand the science about what's going on as these plants grow.
They're looking for high-density plants that grow fast, so they can provide a rapidly renewable source, and a lot of it.
This is tobacco. This is only for studying, not for smoking or chewing, so it's very important to note. And the reason why we use tobacco plants is that it's much like the Arabidopsis. It grows very fast. We understand it very well, and we can determine the impact of these genetic knockouts and genetic engineering on the plant system itself.
Once they've isolated some possible contenders, Simmons gets to work.
This is where the next part of the process from biomass to biofuel occurs.
This is step 2.
This is step 2, exactly right. This is where we take the pretty plants and we break them down into sugar.
So what is all of this right here?
So this is what we need to start with when we get to step 2 of the process, right? So I showed you the feedstocks when they're growing. This is after they're harvested and dried. So this, for instance, is switchgrass that's been milled up and ground up, and that is one of the starting materials that we use.
This step is called deconstructing. They take the dried material and put it through several process steps where it ends up in a liquid state to be analyzed.
We solubilize it and it comes out looking like that. And then when you dry it and recover it, then you get that fine powdery material out. And then you add the enzymes and then you've got sugar.
That's where this special robot comes in. It's designed to help test and develop better enzymes that are critical to the process.
What this does is it basically saves a lot of time, makes the system more efficient, and we can screen thousands of different potential enzymes per day.
But we're not there yet. Once you get the sugars, they're fed to bacteria to produce the fuel. This machine is picking out colonies of bacteria to use. Once the bacteria and sugars are combined, they go into here.
These microbes are actually being grown for the fuel synthesis team. And so they're actually producing the little molecules of fuel from the sugar that we feed them. And then we let them grow for a certain period of time, we bring them out, we harvest them, and then we analyze what they're doing.
JBEI hopes to achieve significant progress within the next 5 years.
There is no bigger problem than global warming that we can work on as a scientific community today that will have a significant and long-term impact.
And Simmons says they're going to use some help.
The United States really needs a next generation of top-tier scientists in mathematics, and I really encourage everybody who's watching this to really think about going into science and engineering as a career. I think it's extremely rewarding, and I hope to see some new fresh faces that can help us out with this effort.
It's an effort that will have a big impact on the planet and on us all.